Look up. On a clear, dark night, away from the glow of our cities, the sky is a velvet canvas, dusted with diamonds. Each point of light you see is a sun, a star, but the light itself is an ancient traveler. The twinkle in your eye is an echo from a time long past. The light from the nearest star has journeyed for over 4 years to reach you. The light from the farthest stars you can see has traveled for thousands. You are, in this very moment, looking into the deep past. But what if we could travel back with that light? What if we could trace its path not to its source, but to its very beginning? Before it was a star, before it was even a flicker, what was it? The answer is both simpler and more profound than you can imagine. It was a whisper in the cold, a ghost in the dark, a cloud of forgotten dust and gas, dreaming of light. And here is the most mind-blowing truth of all. The iron in your blood, the calcium in your bones, the oxygen you just breathed in, every single atom that makes you you, was forged in the heart of a star that lived and died long before our Earth was even formed. You are not just looking at the stars. You are looking at your own cosmic ancestry. You are stardust, awakened. Today we are going on a journey, a slow, calm, and deep journey to witness the most fundamental act of creation in the universe, the birth of a star. If this sense of wonder and connection resonates deep within you, if you feel a yearning to explore the quiet mysteries of our cosmos, then we invite you to join us. Gently press the subscribe button. Share this journey with a kindred spirit, and let us begin. An invitation to stillness. Settle in. Find a quiet space, a comfortable chair. Let the noise of the world fall away, like dust settling in a quiet room. Take a deep, slow breath in, and as you exhale, release the day. Let your shoulders soften. Let your mind become still. We are about to embark on a journey. Not a journey of speed or distance in the way we are used to, but a journey of perspective, of time, of understanding. We will travel across unimaginable voids, not with a roaring engine, but on a gentle current of curiosity. Imagine we are standing on the shore of a vast, dark ocean. This is the cosmic ocean, the space between the stars. And tonight, we will not be looking at the distant lighthouses on the other side. Instead, we will wade into the water, let it hold us, and drift out into the deep, to the places where new lighthouses are being born. Our destination is a place of profound beauty and silence, a stellar nursery. These are not buildings or structures, but immense, sprawling clouds of gas and dust, adrift in the interstellar medium. They are the cradles of creation. Within their cold, dark embrace, the slow, patient dance of gravity is gathering the raw materials of the cosmos, coaxing them into a form that will one day blaze with the light of a new sun. Over the course of our journey together, we will witness this entire process. We will begin by floating through these majestic, silent clouds, these giant molecular cathedrals, learning what they are and why they are the perfect wombs for new stars. We will then feel the first, almost imperceptible stirrings of gravity, the cosmic whisper that calls the dust and gas together. We will watch as a dense core begins to form, a stellar embryo known as a protostar, gathering matter from a swirling disk around it, a disk that may one day form planets. And finally, after millions of years of patient gathering, we will be there for the moment of ignition, the instant that the core becomes so hot and so dense that a new fire is lit in the universe, the fire of nuclear fusion. A star is born. This is more than just a lesson in astrophysics. To understand how a star is born is to understand the origin of warmth, of light, of the very elements that make life possible. The story of a star is the first chapter in the story of everything that follows. Planets, atmospheres, oceans, and eventually, us. The process we are about to explore is not something distant and alien. It is the deep, rhythmic pulse of the universe, and its beat echoes within our own hearts. So let go of any need to memorize facts or figures. Let the information wash over you like a gentle tide. The goal here is not to conquer knowledge, but to befriend it, to feel a sense of connection to the grand, slow, and beautiful processes that shape our universe. This is not a lecture. It is a meditation on creation. Let us take one more deep breath together. In and out, our journey begins. We push off from the shore of the known and drift out into the silent, beautiful dark. The womb of worlds, the giant molecular clouds. Here we are, adrift, suspended in a silence so profound it feels like a presence. We have entered one of the universe's great cathedrals of creation, a giant molecular cloud. Do not think of a cloud in our sky, fluffy and white and transient. This is a different being altogether. It is a vast, sprawling entity, stretching for hundreds of light years. To cross from one side to the other, even at the speed of light, would take a human lifetime many times over. It is immense, yet it is almost nothing. The density here is far, far less than the best vacuum we can create in a laboratory on Earth. If you were to cup your hands here, you might only hold a few thousand atoms. It is the ghost of a cloud, a whisper of matter spread across an impossible scale. And what is this matter? It is the simplest and most ancient stuff of the universe. It is mostly hydrogen, the first element, born in the Big Bang itself. Tiny, single atoms of hydrogen, floating alone in the cold. And helium, its slightly heavier sibling. But there is also a sprinkling of something else, something precious. We call it dust. This cosmic dust is not like the dust in our homes. It is composed of tiny, microscopic grains of silicates and carbon, the stuff of rock and of life. These grains are themselves the ashes of a former generation of stars. Stars that lived, burned brightly, and, in their dying breaths, seeded the cosmos with heavier elements. This cloud, then, is not just a beginning. It is also an inheritance. It is the recycled memory of suns that are long gone. Feel the temperature here. It is incredibly cold, just a few degrees above absolute zero, the point where all motion ceases. This cold is essential. In the warmth, atoms and molecules buzz about with energy, like a restless crowd, preventing anything from settling down. But here, in the deep, profound chill of interstellar space, everything is slow. The atoms are placid, calm, receptive. This coldness is the quiet invitation for gravity to begin its work. As we drift, look at the structure around us. It is not uniform. There are regions that are slightly denser, thicker. Dark, clumpy veins run through the more tenuous gas. These are the molecular cores, the coldest and densest parts of the cloud. It is here, in these pockets of deeper darkness and stillness, that the seeds of new stars are hidden. The cloud is a sleeping giant. For millions of years, it can drift just like this, a silent, beautiful ghost in the galactic currents. It is in a state of delicate balance. The minuscule thermal pressure of its cold gas pushes gently outward, while its own immense, but very diffuse, gravity pulls gently inward. Outward push, inward pull. Cosmic equilibrium. A held breath. But this peace is not eternal. The universe is a dynamic place. The gentle balance of the cloud can be disturbed. The shock wave from a distant supernova, the death of a massive star, might ripple through the cloud like a wave crossing a still pond, or the gravitational pull of a passing star, or even the grand, sweeping spiral arm of the galaxy itself, might nudge the cloud, compressing it, pushing parts of it closer together. Let us pause here, in the heart of this cosmic womb. Let us float in this profound silence and cold. This is the raw potential of the universe. Everything we see in the night sky, every sun, every planet, every moon, had its beginning in a place just like this. An immense, cold, dark, and mostly empty space. It is a testament to the power of patience and the gentle, relentless force of gravity, that from such emptiness, such brilliant light can be born. This is the canvas, and the first brushstroke is about to be painted. The gravitational whisper, the beginning of collapse. Listen, not with your ears, but with your intuition. Can you feel it? A change in the stillness, a subtle shift in the great balance. The held breath of the cloud is beginning to be released in a slow cosmic inhalation. This is the first stirrings of gravity, awakening from its slumber. The trigger could be anything. A nudge from a passing star, a ripple of pressure from a cosmic explosion light years away. Whatever the cause, a region within our giant molecular cloud has been pushed past a critical point. A threshold has been crossed. We can call it the Jeans mass, a beautiful concept in physics which simply means the point at which gravity's inward pull becomes stronger than the gas's outward thermal pressure. The gentle tug-of-war is over. Gravity has won. What happens next is not a violent implosion. It is a collapse, yes, but a collapse that unfolds over hundreds of thousands of years. It is a slow, graceful, and inexorable gathering. Imagine the finest mist, slowly condensing on a cool surface to form a single droplet of water. This is what is happening here, on a scale that dwarfs our comprehension. The clump of gas and dust we are watching, which itself might be several light-years across, begins to contract. The particles on the outer edges feel a gentle, persistent pull toward the center. This is not a dramatic fall, but a slow, inward drift. As the cloud contracts, its gravitational pull becomes stronger still. The closer the particles get to each other, the more powerfully they attract their neighbors. It is a feedback loop of cosmic proportions. A whisper that amplifies itself into a call that becomes a summons. As the cloud fragment shrinks, it begins to fragment further. Like a great cosmic river breaking into smaller streams and tributaries, the collapsing cloud breaks apart into dozens, or even hundreds of smaller, denser cores. Each of these cores is a potential star. Our stellar nursery is now preparing to give birth not just to one child, but to an entire generation, a cluster of stellar siblings, all born from the same parent cloud. Let us focus on just one of these cores. As it collapses, something remarkable begins to happen to the energy within it. The potential energy of gravity, the energy of all those particles falling inward, is converted into heat. The core, which was once just a few degrees above absolute zero, begins, ever so slowly, to warm up. At first, this heat easily radiates away into the cold, empty space around it. The core continues to collapse, shrinking and becoming denser. But eventually, the core becomes so dense, so opaque with dust, that the heat can no longer escape. It becomes trapped. The temperature and pressure in the center begin to rise, pushing back against the relentless crush of gravity. A new battle has begun. Gravity is pulling everything in while the new thermal pressure, born of the collapse itself, is pushing everything out. This is the birth of a protostar. It is not yet a star. It is not yet shining with its own fusion-powered light. It is a stellar embryo, a dense, hot, and growing core, shrouded deep within its dusty cocoon. It glows, not with the fire of fusion, but with the heat of its own contraction. It is a dim, infrared glow, a promise of the brilliance to come. Take a moment to contemplate this process. It began in utter cold and darkness, and through the simple, universal law of gravity, the same law that keeps our feet on the ground and our planet orbiting the sun, a new source of heat has been created. The universe is pulling itself together, and in doing so, it is creating warmth from the void. The patient, silent work continues, deep within the dark cocoon, as the embryo of a star begins to take shape. The growing heart, the protostar and its disk. We have journeyed deeper, through the obscuring veils of the collapsing cloud, and now we behold the heart of the matter. This warm, glowing object at the center is the protostar. It is the stellar embryo, now a distinct and growing entity. It is a churning, turbulent ball of hot gas, 100 times the size of our own sun, but not yet a true star. It is still gathering its mass, its substance, from the parent cloud. Material is still raining down upon it, a steady, cosmic drizzle that has continued for millennia. This process is called accretion. The protostar is feeding, growing, becoming ever more massive and dense. Each particle that falls onto its surface adds to the gravitational crush, increasing the temperature and pressure in its core. But notice the material is not falling straight in. Look around us. The protostar is surrounded by a vast, flattened, rotating structure. This is an accretion disk, or, more poetically, a protoplanetary disk. Its existence is a beautiful consequence of a fundamental law of physics, the conservation of angular momentum. Think of an ice skater spinning. When she pulls her arms in, she spins faster. The initial, slow, random tumbling of the parent cloud contained a tiny amount of rotation. As the cloud collapsed, shrinking from light years across to the size of a solar system, that slow tumble was concentrated. The cloud had to spin faster and faster. This rotation prevented the material from falling directly onto the protostar. Instead, it flattened out into this magnificent disk, a cosmic whirlpool swirling around the growing stellar core. This disk is a place of immense importance. It is not just feeding the star. It is the birthplace of future worlds. Within this rotating expanse of gas and dust, the same process of gravity and accretion is happening on a smaller scale. Tiny dust grains stick together, forming pebbles. Pebbles collide to form rocks. Rocks merge to form planetesimals, the building blocks of planets. For every star that is born, a disk like this offers the potential for a family of planets to accompany it. The birth of a sun and the birth of its worlds are intimately, inextricably linked. They are born together from the same swirling cloud. The protostellar phase is a dynamic, almost chaotic period. The young, growing star is not yet stable. As material from the disk funnels onto its surface, the protostar can have violent outbursts, becoming suddenly brighter before dimming again. It is also a time of great cleansing. Look to the poles of the protostar, above and below the flat plane of the disk. Do you see them? Immense, powerful jets of gas, blasting out into space for light years in either direction. These are bipolar jets. Driven by the intense magnetic fields of the rotating protostar, they act as a cosmic pressure release valve. They clear away the remaining gas and dust from the immediate vicinity of the star, carving out great cavities in the surrounding nebula. It is the star, even before its true birth, beginning to shape its own environment, pushing back the very cocoon from which it is emerging. Let us hover here, in this place of dynamic creation. We are witnessing a system in formation, a central, glowing heart, feeding and growing. A vast, rotating disk, a cosmic potter's wheel, shaping the raw material for future planets. And powerful jets, the star's first breath, announcing its presence to the cosmos. The protostar is a bridge between the cold darkness of the molecular cloud and the brilliant fire of a true star. It is a process of becoming. For hundreds of thousands, perhaps millions of years, it will exist in this state, patiently gathering mass, its core growing ever hotter, ever denser. The pressure is building. The final, critical threshold is approaching. The universe is holding its breath one last time, waiting for the moment of ignition. The first light, the birth of a main sequence star. We have reached the final act of our creation story. We journey now into the very center of the protostar, a place of unimaginable temperature and pressure. The patient work of gravity, over millions of years, has led to this moment. The slow, relentless collapse has concentrated matter to a density far beyond anything on Earth. The core temperature, which started near absolute zero, has climbed steadily, past thousands, past millions of degrees. The core of our protostar is now a crucible. The pressure is immense, a weight so great it seeks to crush the atoms themselves out of existence. The temperature has reached a staggering 15 million degrees Celsius. At this temperature, matter cannot exist as we know it. It is a plasma, a roiling sea of atomic nuclei and free-flying electrons, stripped from their orbits by the sheer heat. Specifically, we have a sea of protons, the nuclei of hydrogen atoms. They are zipping around at incredible speeds, but they are also being squeezed together by the overwhelming force of gravity. Protons, being positively charged, naturally repel each other with ferocious intensity. The closer they get, the stronger the repulsive force. It is a fundamental barrier, like two powerful magnets of the same pole pushing each other away. Under normal circumstances, this electromagnetic repulsion would always win. Protons would never get close enough to touch. But here, in the heart of a star, two incredible forces are at work: the crushing pressure of gravity and a strange, wonderful phenomenon of the quantum world. The pressure is so great that it forces the protons into impossibly close quarters. And at these tiny distances, something miraculous happens. Quantum tunneling. Proton can, in a sense, cheat. It can borrow a little energy from the universe itself, and instead of needing to climb over the repulsive barrier, it can simply appear on the other side. It tunnels through the wall that should have kept it separate. And in that instant, when two protons are forced to touch, a new force takes over. A force that only operates at the tiniest subatomic scales, the strong nuclear force. It is phenomenally powerful, and it binds the protons together. In that moment of binding, the alchemy begins. One of the protons transforms into a neutron, releasing a positron and a neutrino. A new nucleus is formed, deuterium, an isotope of hydrogen. This process, happening trillions upon trillions of times every second, is the beginning of nuclear fusion. This is the spark. The furnace has been lit. The process continues. The new deuterium nucleus is quickly struck by another proton, forming a nucleus of helium-3. And finally, two of these helium-3 nuclei collide, fusing to create the stable, familiar nucleus of helium-4, and in the process releasing two protons to begin the cycle anew. Here is the secret of the stars. Here is the source of all their light and energy. If you were to weigh the final helium-4 nucleus and compare it to the weight of the 4 original protons that went into making it, you would find that the helium nucleus is slightly less massive. A tiny fraction of the mass has vanished. Where did it go? It was converted directly into pure energy, according to Einstein's most famous equation, E equals mc squared. Energy equals mass times the speed of light squared. Because the speed of light squared is such an enormous number, that tiny amount of lost mass is converted into a colossal amount of energy. This energy, born in the core, begins to push outward. It is an incredible, constant outpouring of light and heat. This outward radiation pressure is the star's own power, pushing against the inward crush of gravity. The star expands slightly, and then settles. Perfect equilibrium is reached. The inward crush of gravity is now perfectly balanced by the outward push of fusion energy. Hydrostatic equilibrium. The star stops contracting. It is now stable. It is no longer a protostar, glowing from the heat of its collapse. It is a true star, a main sequence star, shining with the glorious, self-sustaining fire of nuclear fusion in its core. A new light shines in the cosmos. A journey that began in a cold, dark cloud has culminated in the birth of a sun. For millions or billions or even trillions of years, it will hang here in the void, converting hydrogen into helium, radiating light and warmth into the space around it. It is a beacon of stability, a source of energy for any future planets that may be orbiting it. Let us rest here for a moment and bask in the light of this newborn star. Contemplate the journey, from the silent potential of the cloud, to the gentle whisper of gravity, to the messy, beautiful dance of the protostar, and finally, to this moment of incandescent birth. This is the rhythm of the universe. This is the way the cosmos makes light. In-depth exploration, the alchemical heart and a spectrum of souls. The delicate dance of fusion, a deeper look. We have witnessed the moment of ignition. Now let us linger and understand this miracle of fusion with a little more intimacy. Let us slow down time itself and watch the delicate, cosmic alchemy that powers our newborn star. Imagine the core is a grand ballroom, impossibly crowded. The dancers are protons. They are energetic, moving swiftly, but the dance floor is so packed by gravity's immense pressure that they are constantly bumping into one another. However, each dancer is surrounded by a powerful, invisible field of repulsion. They can get close, but they cannot touch. For fusion to happen, they must overcome this field. This is where the magic of the quantum realm steps in. Let's watch two protons on a collision course. They rush toward each other, their repulsive force growing stronger, slowing them down. It seems they will simply bounce off each other, as they have done a billion times before. But this time is different. In the tiniest fraction of a second, one proton doesn't break through the barrier, it simply appears on the other side. This is tunneling. It is not an act of force, but an act of probability. It is as if the proton, for an instant, existed in all possible places at once, and one of those places was on the other side of the wall. Let us pause here and contemplate this. The very light of the stars, the foundation of their existence, relies on a principle that defies our everyday intuition. It is a reminder that the universe operates on rules far stranger and more beautiful than we can perceive directly. The solid walls of our reality are, at their deepest level, merely strong suggestions. Now that our two protons are bound together by the strong nuclear force, the alchemy can truly begin. The moment they are joined, one of them fundamentally changes its nature. It sheds its positive charge by emitting a tiny particle called a positron, the antimatter version of an electron, and an almost massless, ghost-like particle called a neutrino. The proton has become a neutron. The two are now bound as a single nucleus, deuterium, also known as heavy hydrogen. This first step is the most difficult and slowest part of the entire process. It is the bottleneck that allows a star like our Sun to burn its fuel slowly and steadily for billions of years. The neutrino, a true ghost of a particle, flies out of the core, out of the star itself, at nearly the speed of light, barely interacting with anything. Trillions of them are passing through your body, through the entire Earth, every single second, silent witnesses to the fusion in our Sun's heart. The positron, however, immediately finds an electron in the crowded plasma. Matter meets antimatter. They annihilate each other in a tiny, pure flash of energy gamma rays. Our dance continues. The newly formed deuterium nucleus is soon struck by another energetic proton. Because the deuterium nucleus has a lower charge barrier than two individual protons, this collision happens much more easily. They fuse instantly. Now we have a nucleus with two protons and one neutron. This is a light isotope of helium called helium-3. This fusion also releases a powerful burst of energy in the form of a gamma-ray photon. This is where the choreography gets truly elegant. For the final step to occur, this entire process must happen twice. Somewhere else in the core, another helium-3 nucleus has just been formed through the same sequence of events. Now, our two helium-3 nuclei, the products of two separate dance sequences, find each other in the roiling plasma. They collide and fuse. In this final, climactic step, they rearrange themselves. They form one, supremely stable nucleus of helium-4, which consists of two protons and two neutrons. The two extra protons that were part of the helium-3 nuclei are kicked out, freed to begin the entire dance all over again. This is the proton-proton chain, the primary way that stars like our Sun generate energy. Four hydrogen nuclei have become one helium nucleus. And in that transformation, a fraction of a percent of their mass has been converted into the light and heat that will travel from the core, through the star's immense body, and out into space. A single photon of light created in this dance may take 100,000 years to journey from the dense core to the star's surface, bouncing from atom to atom in a long, random walk. But once it is free, it will cross the void, perhaps to land on a distant world, to warm a future ocean, or to enter the eye of a creature wondering about the stars. Every single photon is a messenger, carrying the story of this beautiful subatomic dance. A spectrum of souls, the lives of different stars. Our star has been born. It has settled into its long, stable adulthood, which astronomers call the main sequence. But just as no two people are exactly alike, no two stars are exactly alike. The path it took to get here, and the life it will lead, was determined by one single crucial factor: its mass. The amount of material it managed to gather from its parent cloud during its formation. Let us expand our view and look upon the grand family of stars. They are not all the gentle yellow-white of our newborn sun. Look there. See that brilliant, piercingly blue-white star? That is an O-type star. It was born from a much larger, more massive core in its molecular cloud. It is a cosmic titan, 30, 50, even 100 times more massive than our sun. Because of its immense mass, the gravitational pressure in its core is titanic. To fight against this crush, it burns through its hydrogen fuel at a furious, profligate rate. It is incredibly hot, incredibly luminous, bathing its surroundings in fierce ultraviolet radiation. But this brilliance comes at a cost. Its life is a short, spectacular sprint. It will burn through all of its fuel in just a few million years, a mere blink of an eye in cosmic time, before dying in a cataclysmic supernova explosion. They are the rock stars of the cosmos. They live fast and die young. Now let your gaze soften. Look for the most common stars of all, though they are the hardest to see. The dim, small, reddish points of light. These are M-type stars or red dwarfs. They are the other extreme. They were born with very little mass, sometimes less than a tenth of our sun's. The pressure in their cores is modest. They sip their hydrogen fuel with incredible efficiency, fusing it so slowly that their light is faint and their temperature is cool. They are the quiet, contemplative monks of the universe. Their lifespans are almost beyond our ability to comprehend. Not billions, but trillions of years. Longer than the current age of the universe itself. Every red dwarf that has ever been born is still shining, still in its stellar infancy. They are cosmic embers that will glow long after the last of the brilliant blue giants has faded. And then, there are stars like the one we watched being born, a G-type star like our own sun. It sits comfortably in the middle. Not too hot, not too cool. Not too massive, not too small. It burns its fuel at a steady, reliable rate, creating a stable output of energy for 10 billion years. It is this stability, this longevity, this gentle nurturing quality that makes stars like our sun such wonderful hosts for life as we know it. They provide a long, predictable summer in which the slow, patient process of evolution can unfold on its orbiting planets. Astronomers map these stellar souls on a beautiful chart called the Hertzsprung-Russell diagram. It is not just a graph of temperature versus luminosity. It is a map of stellar lives. The long, diagonal band across the middle is the main sequence, the adulthood where all stars spend the vast majority of their lives, fusing hydrogen into helium. The giants and supergiants that sit above it are the elderly stars, in their final, expanded phases. The white dwarfs that lie below are the dense, cooling corpses of stars like our sun. By looking at this family portrait, we see a profound truth. The universe creates not in monochrome, but in a rich and varied spectrum. Each type of star, from the fleeting, brilliant titan to the enduring, dim ember, plays its part in the cosmic ecosystem. The massive stars create and scatter the heavy elements necessary for life. The long-lived stars provide the stable havens where that life can take root. It is a system of breathtaking diversity and interconnectedness. The birth of a star is not the creation of a single object, but the introduction of a new soul, with its own unique personality and destiny, into the grand, cosmic family. Conclusion: the stardust within. Our journey is drawing to a close. Gently, we drift back from the deep ocean of space, back toward the familiar shore of our own perspective. Let us take a moment, in the quiet, to let the echoes of our journey settle. We have traveled far. We have floated through silent, cold cathedrals of gas and dust, the wombs of creation. We have felt the first, almost imperceptible whisper of gravity, the gentle summons that begins the great work of creation. We have watched as a swirling disk of potential worlds formed around a glowing, growing stellar heart. And we have stood in awe before the moment of ignition, the lighting of a new cosmic furnace, the birth of a star. We have seen that this birth is not a single event, but a long, patient, and beautiful process. A dance between gravity and pressure, between cold and heat, between darkness and light. We have learned that the starlight that reaches us is not just light. It is a story. It tells of a journey from a diffuse, cold cloud to a blazing, fusion-powered core. It speaks of the quantum strangeness that allows suns to shine, and the rich diversity of stellar souls that populate our universe. Now, as we return, bring this understanding back with you. The next time you feel the warmth of the sun on your skin, remember the core. Remember the delicate dance of protons, the conversion of mass into the energy that sustains you. The next time you look up at the night sky, at the scattered points of light, see them not as distant, cold objects, but as living, breathing entities. See them as the brilliant blue titans, the gentle yellow nurturers, the ancient, enduring red embers. See them as a family, and most profoundly, feel the connection within yourself. The story of the birth of a star is not separate from your story. It is your story. The iron that allows your blood to carry oxygen was forged in the heart of a massive star that died in a supernova explosion, seeding the cloud that would one day form our sun. The calcium that gives your bones their strength, the carbon that is the backbone of your DNA, Every heavy element that makes up your body, this planet, and everything you have ever touched was created through the life and death of stars. You are not merely an observer of the universe. You are a participant. You are a living, breathing, thinking embodiment of its creative processes. The cosmos is not out there. It is in you. We are, in the most literal sense, stardust, given the profound gift of consciousness. We are a way for the universe to know itself. So let this journey not be an end, but a new beginning for your own sense of wonder. Carry this feeling of peace and connection with you. Let it be a reminder of the vast, slow, and beautiful processes that are always unfolding, both on the grandest of cosmic scales and within the quietest corners of your own being. If you wish to continue these quiet explorations with us, to journey to other wonders of the cosmos, we would be honored to have you join our community of fellow travelers. But for now, the journey is complete. There is nothing more to do, nothing to learn. Simply be. Take a final, deep breath and wonder.